Okay, question 43. It says that we've got standard electropotentials associated with half equations on the electrochemical series are determined from the cell voltage generated when the half cell is connected to the standard hydrogen half cell. Describe the components and conditions present in a standard hydrogen half cell. So if you remember when they are gathering the electropotentials for the standard hydrogen half cell, there are certain conditions that information is being collected at. So we've got it's a 1 molar hydrogen plus electrolytic solution. We're using a platinum electrode. The hydrogen gas is at 100 kilopascals and at 25 degrees. So it's at standard lab conditions. Part B, if it's working. Okay, part B. Write an overall equation describing the cell reaction occurring when a standard hydrogen half cell is connected to chloride gas and chloride ion. So chloride gas and chloride ion. So here I've just cut and paste our electrochemical series from our data booklet. So I've got my chloride gas and I've got my chlorine gas and my hydrogen gas. So if we remember, we have over on our left as we go up, that is our stronger oxidizing agent, and we've got our stronger reducing agent. So that means here our stronger reducing agent undergoes oxidation, and up here will undergo reduction. So this will go oxidation, and this here will undergo reduction. So if we remember, all these equations here are the reduction equation. So when we're going from reading the equation from left to right, that is, it's undergoing reduction. If it's reversed, we're reading it from right to left, it's undergoing oxidation. So it wants us to write an overall equation. Okay, so I know I've got my Cl2 gas, I'll write these equations out, plus 2 electrons, okay, it's undergoing reduction, and it's forming 2 chloride ions, okay? Then I'm really bad at writing. Okay, then we've got our hydrogen gas. It's undergoing oxidation. So we're writing it this way. 2 hydrogen ions. Yes. Okay. Plus 2 electrons. Okay, so if we remember when we are writing our overall equations, we want the number of electrons to be the same. So we've got 2 electrons, so we don't need to do anything. So what will happen is if we just combine these equations, those electrons will cancel out, and I add what I've got left. So I've got chlorine gas plus hydrogen gas will give me 2 chloride ions. And 2 hydrogen ions. Okay, and that is my overall equation describing the reaction that occurs. Okay, good. Okay, C. In a different galvanic cell containing the standard hydrogen half cell, the pH in the standard hydrogen half cell decreases as the cell delivers energy. Okay, so that means we've got the pH decreases. This is where a few people get confused. So I've got my pH, just write a little summary, decreases. Okay, so that means it's going from, say, 3, just making this up, 3 to 2. Okay, because some people get confused when they say the pH decreases. They read it as in it's going from 2 to 4, okay, but it's decreasing, okay? So that means it's getting more acidic. So as it's decreasing that pH, so say it's going from 3 to 2, it's becoming more acidic, okay, more acidic, okay? And if we remember that that our pH is a measure of our hydrogen ions and the number of it, okay? So that means that if it's decreased in pH, I'm going to have more hydrogen ions present. Okay. So explain how this knowledge enables you to deduce the sign of the electrode in the standard hydrogen half cell. Okay, so I know that the pH decreases. that means that there's more hydrogen ions in there. Okay, so as my half cell is running. So if I go back here and I look back in my data booklet, I've got the equation here. So I'm getting more hydrogen ions being produced, okay, because the pH is decreasing. So that must mean that the reaction is occurring from right to left. Okay, so it's occurring right to left. So that must mean that my hydrogen gas is being oxidized. Okay, so if it's being oxidized, that must mean that it's occurring at the anode, which must mean that the electrode is negative. Okay, so there's a few little things just to put together in that question. D. In an alternative version of the electrochemical series, standard electrode potentials are determined by using the copper half cell as a reference half cell. Okay, so that's my copper there. Okay, so normally, where is it? Normally it's my hydrogen here at 0. That's my standard half cell. But this time we're using copper as a reference half cell. Okay, assuming the same standard conditions apply, what would be the standard electrode potential of nickel in this alternative electrochemical series? Okay, so that would now mean that we are making our copper 0. Okay, because if we see when our hydrogen is the reference cell, it's set to 0. Okay, so that makes copper 0. So that would mean that the difference between these stays the same, but each individual will differ. Okay, so if the difference is staying the same, that must mean that there was a 0.34 difference, okay, between copper and hydrogen. Okay, so that must make that 0.34. And there was a 25 difference between this. Sorry, it's going to be negative, isn't it? Oh, it's writing. There's a 25 difference between this. Okay, so another 25 difference between this. This must make this negative 0.59. Okay, because here was a difference of 0.34. Okay, but that's now set at 0. Okay, so that's now negative 0.34. And then there's a 25 difference between these two still, because the differences still remain the same. It's just the individual electrode potentials that are changing. So then that must mean if I've still got a 0.25 difference, then this must be negative 0.59. Okay, because I've still got that same difference of 0.25.